Hello, welcome again. Josh, your tech guy right here. In today's video, I'm going to focus on computer science degree. So in this computer science degree, I'm going to focus on what you're supposed to cover for the 4-year course. So personally, I'm going to share the experience of what I underwent for the 4 years when I was taking my undergraduate degree. And after that, I think it's going to help one or two people out there who are planning to join the computer science class and tech unit in that case. Okay, so I went in one of the Kenyan public universities and I majored in computer science. When I was joining as an undergraduate student for the first year, I remember having joined the school as a fresh student and being introduced to the core values of the university and the mottos and stuff. From what the motto of the school was, the foundation of innovations, I think it went with what I really wanted to do when I wanted to join university. I want to be an innovator, come on with several series of innovation platforms in tech and stuff like that. So I I satisfied the general requirements and educational requirements which were required for me to join the School of Computing and take computer science as a career, as an undergraduate degree in that case. And then what I did is I really focused on my unit and I really did good. Some were so hard, some were not hard, some were not my thing. But at the end of the day, I ended up performing well. So what I'm going to share with you today is what I did in the 4 years. So here one, the first year of taking my computer science degree, I covered around 15 units, and in these 15 units, some were basic, some were more of introductions into the various units which I was supposed to cover in the broader perspective when I was to proceed to second, third, and fourth year respectively. Okay. So like I did a unit called SCIT 3100. This was a course which was focusing on computer technology, introduction to computer technology. This is where we were introduced about basic technologies which exist in computing world, and we did a lot. I think it was an enjoyable course. The second one was fundamentals of computer programming. In fundamentals of computer programming, we were able to study the language called programming in C, where we did the printf and scanf stuff like that. That was on programming in C. Then I did fundamentals of internet, where we studied the basic HTML elements, and we were shown how to sort of develop some simple website using the HTML tags, the creation of tables, creation of navigation bars and stuff like that. And then we did a unit called Mathematics for Science. Mathematics for Science was more of advanced high school mathematics, where we were doing some sort of mathematics. It was so interesting. And then from there, we did what we call discrete mathematics. In discrete mathematics, we were taught about the set theories and stuff like that. And then we did another one on communication skills. This was to basically prepare you in terms of inter and interpersonal skills, which can help you to sort of do some demos when you're presenting a project, so that you don't get problems when you're talking to people. And then I did obvious HIV and AIDS, which is a common unit in every student who joins the university in our curriculum in 844 in Kenya. And then after that, I did computer systems architecture. This was a unit which gave me a lot of headache, being a first year in university, and then you've not covered a lot, you've not known much about the computer. So we did a lot of computer systems architecture. That was on my first year. And then after that, we did what we call data communication and networks. This was focusing on the topologies and on how data is being transmitted on a network and how these things work together. And we were introduced to basics of distributed computing, which we'll cover in the next year, I think, in one of my records here. And then after that, we did object-oriented programming 1. In the object-oriented programming 1, we were introduced to programming in C++, which was an advanced programming from C, whereby you will notice that there's a difference between programming in C and programming in C++. Of course, both of the two languages can be used to code sort of embedded softwares and stuff like that. And then after that, we did what we call system analysis and design. That was an SAD unit, which we did and give us a lot of challenges. I remember struggling to sort of understand what it really meant, because it had a lot of theories and stuff like that, but it was a nice introduction, because this is what you need when you want to do your final project. And then after that, we did a differential and integral calculus. This is calculus which was combined, calculus 1 and calculus 2 combined. So you have to do differentiation and integration at the same time, so that you come up with something we call differential integral calculus. It had a lot of math. I remember being taught by some professor who usually gave us a lot of problems in terms of understanding this, because you could have understood integration and then integration on integral calculus, and at the end of the day you're given a question focusing on differentiation, and then you could have a lot of challenges in solving that. But be prepared to have that unit on board. Then after that, we did a unit called discrete structures, where we were dealing with it was more of advanced discrete mathematics, set theories and stuff like that. But in discrete mathematics, we were sort of dealing with discrete structures and how they were really working in a math. It is a math unit that is more of computing and mathematics on both sides and stuff like that. And then we did another unit of general physics. In general physics, we were introduced to the basic, the advanced physics that is basically different from what we did in high school and stuff like that. And then from there, the last unit we did in first year was probability and statistics, where we were learning some sort of how to do some summations on probabilities and statistics, functions on mean, mode, and average and stuff like that, and more on the SATs theory and stuff like that. Okay, and then my second year, this is a year which was advanced from what we did in the first year. So in my second year, I did 17 units, and I'm gonna go faster to the alighting of this unit, so that we can be having a wider picture of what I'm talking about. I did data structures and algorithms. This is where we started about the predictive first search, backtracking, and a lot of algorithms in these sections. All the algorithms that we were covering, they were on the DSA, data structures and algorithms. After that, we did a unit in software engineering. Software engineering was one of the units we did in second year, where we were talking about how a software engineer should be, the principles and stuff like that. And then after that, we did the database systems. This was an advanced database unit which we covered in first year. So we were doing it in an advanced level. We were doing database design, database implementations and stuff like that, working with the database management the systems, the RDBMS and DBMS management systems. So this is what we covered in our second year. And then after that, we did operating systems. This is where we were talking about my memory management, file management, error handling and stuff like that. After that, we did network design and implementation, where we were studying the basics of the Linux operating system. We were talking about Unix and Windows. We were differentiating on how the two operating systems work, and going in depth on how command line interfaces work with line user interfaces and stuff like that. After that, we did what we call object-oriented programming 2. This is where we did Java, where we were writing some Java objects and classes there, implementing methods and stuff like that. And after that, we did numerical linear algebra. In numerical linear algebra, we were focusing on basically doing some sort of linear algebra, which was advanced in an advanced level. In fact, it was a very good mathematical class, where you could have basically studied some principles like some formulas of Jacobi Gauss Jordan rules and stuff like that. And then after that, we did a unit in electronics. This was a unit which was advanced. This was advanced general physics, where we were studying about the gates, the NAND gates, the logic, the computer logic and stuff like that. And after that, we did object-oriented analysis and design. This is where we were thought about of making UML diagrams and designing of how you can come up with a code mock-up and stuff like that. And then after that, we did wireless and mobile computing. Here we were studying on how the mobile networks operators communicate in a dedicated server. For example, we could say about how a phone call is being made, about the bus stations, about the nano stations, and how signals are being sent from here to the satellites and stuff like that. After that, we did a unit called assembly language programming. This is where we were learning more about the computer kernel and how the TASIM and FASIM languages operate, how the computer works from the inside. It was also one of the toughest units I encountered when I was doing my undergraduate, but I found it interesting later after understanding what it really meant. You have to be very keen when taking assembly programming language. Then after that, we did automata theory. This is where we were talking about the Turing machine. We were talking about the finite and infinite automaton. And then we started a lot of logic here. It was really important on how problems being solved from an wider view. I did a video before about automata theory, the theory of computing. I think you can have a look at it, and it explains better on what automata theory is all about. And then after that, we did our industrial attachment one, which was lasting for 8 weeks. Here was attached to a software company where I was trying to do some software development using PHP platform and stuff like that. After that, we did another unit called network administration and management. This is whereby we were studying on how to manage networks and stuff like that. It's more of advanced data communication. Then after that, we did PC maintenance and a networking lab. Here we were studying the hardware of a computer, on how you can do some basic troubleshooting when we're having a computer in a hardware perspective. It was more of a practical session where we were doing this stuff from our lab and stuff like that. And then lastly, we did a unit called digital logic. This is where we were studying about the gates, the NAND gates, the OR, the XOR, the OR gates and stuff like that, how these gates come on board and lead to communication channel flow. And this was actually the point where I came to understand what computer science was meaning. And then after that, I went to graduate to the third year. That is the second last year in my final stay at the university taking computer science. And in my third year, I did a general of 16 units. The first one is design and analysis of algorithm. In design and analysis of algorithms, we were able to discuss algorithms in further details, understanding each algorithm, how it works. For example, how backtracking works, how maybe when we talk about greedy algorithms, a greedy algorithm, how it works and stuff like that. And then we did systems programming. In systems programming, we were basically, I don't remember well, but we were covering something about how systems are programmed, how they communicate using, we were using C++ as a language to learn this, how basically we have the input, the I/O devices, how they communicate from outside to the inside. Maybe you have a USB port, you want to plug it into the computer, how the I/O devices communicate. I think this is what we covered in system programming. Then after that, we did Ict Project Management. This is where we were introduced to how to manage a project, how to come up with a project, how to design all this and come up with a better workable solution. Then after that, we did a HCI, or human computer interaction. This is where we were studying on how computers interact with users or human beings in terms of usability engineering, in terms of UX and UI, the user interfaces and user experiences. This is where we studied a lot about it. And then after that, we did internet application programming. This is now where we were applying our fundamentals of internet into internet application programming. We did basics of PHP, where we learned how to connect the databases to a website and how to retrieve information, store, deletion, update, addition of information and stuff like that. So this is where we started more of now coming up with something which is workable or system. Okay, and I did a couple of systems supporting C#, Java, PHP, some sort of Django in Python and stuff like that. After that, we did multimedia systems and application. This is where we were studying more of our output devices, work from our various devices that we have. After that, we did numerical analysis. Numerical analysis was one of the units which was more of math, where we were doing a lot of analysis of how we can generate some unique codes when we have a very huge problems and stuff like that. After that, we did artificial intelligence. Artificial intelligence focuses majorly on training you on how some components work outside there. For example, a robot, how a robot works, how an agent work, like an intelligent cleaner, how it works, how does it recognize this is a corner and navigate and stuff like that. So you can program a certain device to perform a function like a drone. Those are some of items which uses AI in that case. So we did a lot of Java here, socket programming and stuff like that. So, and then after that, we covered another unit called distributed systems. In distributed systems, we were able to do more of the data communication. It's more of data communication, how we can have several the machines or several devices communicating to the same network over a wide period area. We can talk about local area network, wide area network, metropolitan area networks and stuff like that. After that, we did another attachment, which was the final one. We usually went to attachments as per the school. The first one was to be in second year, and the second one should be on your third year, so that in the fourth year you can do internship as you wait for your graduation or something. Yeah. After that, we did research methodology and group project. This is whereby we were able to come up with one single project. We were assigned a group of like 5 people and work on a specific project and come up with one before you are given your final project to do. Okay. And then after that, we did programming languages. Programming languages is a unit whereby we would study on how you can, or how one can come up with their own programming language and those logics behind what you need to consider, like what are those considerations you need before you come up with a programming language. Yeah. Then after that, we did another unit called mobile application development. This is whereby we were studying on Android, purely Android, on how to write Android apps, programs and stuff like that. We were focusing on Java. It was a pretty interesting class where we came up with several jogging around developing interfaces and some workable mobile apps. So it seems really good to do that. After that, we did another unit called simulation and modeling. In simulation and modeling, this is one of the hardest units I encountered. It's actually done by actual students, but we did this, and the basic reason why we're doing this is because we were focusing on doing some sort of simulations on how you can simulate a specific scenario and then model to come out with a given solution. But it was a hard unit to bait. It's not an easy one, but I managed to go about it. And then after that, we did excuse me, we did another unit called operations research. This was another math unit. And then after that, in my final year, I can say in my fourth year, I did another 16 units, and they are as follows. The first one is called knowledge base system. So in knowledge based system, or KBS, this is where we're focusing on checking on how systems basically work. How do systems work? How do they like become intelligent? It's more of an AI unit, but sort of more theoretical, and tries to understand how systems basically communicate. All right. And then after that, we did an embedded system unit, and this unit it was a class whereby we could sort of come together and study on how we can write, embedded systems, like, look at a watch and how can you write some, or a robot. Okay, we could study Arduino programming, using Arduino C, and sort of model that to come and make sure that that device is performing some given function. So that's what we call embedded system, writing small programs for smaller components which are embedded, which is like a chip, something we can carry on our answer sizable hand and stuff like that. Then after that, we did another unit called computer security and cryptography. In this unit here, I remember we did a lot of content on studying on how we can encrypt and encrypt data of a communication channel. You were talking about a lot of encryption methodologies and encryption methods. We did a lot of math here. It was also an interesting project, unit or class. Okay. Then after that, we did computer systems project. This is a proposal whereby you're going to write a proposal of the project you can sort of work on and come out with it. Before graduating, you need to present a workable project. So this is where I designed to do some online voting system, where I implemented some AI methodologies and stuff like that, and it really worked well. And after that, we did a unit called cloud computing. Cloud computing is a unit which was introducing us to the web, the cloud, the Amazon Web Services. Like, talk about AWS, talk about Kubernetes and stuff like that. How what these cloud services rendering our services? Like, you have done an application, how can you store it? How can you run it from the cloud-based environment and stuff like that, right? Then after that, we did computer graphics. In computer graphics, we did a lot of Java. We were trying to see that how can you write a program to come up with a specific graphic. How can you just model? How can you just come up with a graphic? So it's more of showing you the way to go. And then after this, you can develop some sort of graphic which performs something. Talk of cartoons. When you talk about cartoons, that's computer graphic programming. That's graphics. How do you develop that? That's what we did in that unit. Then after that, we did business intelligence and analytics. In this, we were talking about the big data and the exabytes, how data is being deployed outside there, how we have huge amounts of data nowadays. People are becoming many. We have a lot of devices storing a lot of information. So in that case, we really need to have a lot of, we were talking about the three V's. We're talking about the velocity, the volume, and variety. So we have data existing in a lot of varieties, a lot of volumes, and a lot of the other V. So this data can be structured or non-structured. How can we store this data? So the storage aspect brings about the issue of business intelligence and analytics. We have to look at analytic tools. We need to look at like the hash maps and stuff like that, how they store data and stuff like that. So after that, we did another business unit called financial accounting. This is whereby we were studying about the how you can debit and credit. It's more of finance related. If you did business in your high school, you can be able to manage this unit very well. After that, we did another unit called compiler construction. So in compiler construction, it's more of automatic theory. It's about theory of computing, how the computer basically does the compiling thing behind the scene. We see the computer from the front end like this. We don't know what happens in the back of the mind. You have written a program, you feed it to your compiler, the compiler goes through it. If it has bugs, it's going to throw an error and tell you that, we have an error in this section. So that's why we came up with the computer compiler construction. So we were able to construct some compilers and stuff like that. It's more of a theoretical class, but it was a good one anyways. Then after that, we need emerging technologies in computer science. This was a class which was focusing on teaching us on how the world is really growing, where we're heading as a country. We were talking about virtual reality, we are talking about simulated environments, we were talking about it's the quantum computing. We're talking about what we have, the Bitcoin and stuff like that, cryptocurrency. So these are the things we're covering when we're talking the emerging trends in computer science. You'll find that due to the computer science demand and knowledge is being expanded on day-to-day basis, people have gone out there and they want to have more things coming on board. So they've gone to mine, like when we talk about cryptocurrency, the Bitcoin, the forex trading and stuff like that. Okay. After that, we did another unit called neural networks. Now this is a crazy unit whereby we were studying about the neural networks, how the sensory neurons, it was more of biology, how the mind, takes information and it gives us back feedback. So in neural networks, we were looking at it from a computer perspective, where we're talking about the sensory neurons in computing, whereby information is being fed and then it throws out the whole concept, gives us the information. It was one of the tricky units that to understand you really needed to sort of sit down and think and have some logic on your mind to crack that and come out smart. Then after that, we had digital image processing. In digital image processing, it was more of an advanced computer graphics sort of unit. It was a mathematical class whereby we did a lot of math in terms of trying to come up with digital images, like sort of you write a program which can sort of give an output of an image which is more digital than more of analog picture and stuff like that. It's more of advanced, it's related to computer graphics or something. Yeah. So after that, we did another unit called computer system project implementation. This is whereby now you, after the project proposal writing, you could come down and now start the coding thing, from analysis, from planning, from come on to implementation, come on to testing and everything, maintenance. You come up with a code, you come up with a workable interface that you can present to people and show them, what, I've been working on ABCD and this is what I came up with. So this is what we did in that case. And then the other unit we did was on the GIS. When I talk about GIS, is Geographic Information Systems. This is whereby we were trying to study on how the basically information is being mapped on our geographical information systems, or the satellites, and how we can extract this information and represent it on our computers and come up with digital data. So it was some of more of geographical information, studying about the earth, how the satellites communicates and send signals down here and stuff like that. After that, we did professional ethics used in computing. This is whereby we were trying to study law in computers. We have laws in everything. We have a law and how these laws are applying to computer science. So if you're an IT person or computer scientist and you're facing a law like anybody who is in another but in a different format, we're talking about data privacy, we're talking about data confidentiality, we're talking about how to go about if someone has like violated your information from the internet and stuff like that. And the last unit I did in my 4-year course in university was entrepreneurship, where basically you were taught how you can run a business, you can become a best entrepreneur in the field of computing and stuff like that. So guys, I think that's all for today, and I think this was really helpful for someone who is going to take the computer science course. I've basically highlighted all the units, basics, the 4 units I did when I was a student in university taking computer science as a degree. And I hope to see you in the next one. Please, before you make a decision on which unit you're going to do or which major you're going to focus on, just try to go around, try to consult your professor, to consult your advisor, career advisor, try to check from people from LinkedIn account.